Okay, today we're going to be looking at the coin toss problem. In the coin toss problem, a fair coin is randomly tossed repeatedly until a string of 5 consecutive heads results is obtained. For example, the following results would lead to the flipping of the coin stopping, because you stop when you get to 5 heads in a row. So if you have heads, 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 you obviously stop because that's 5 directly in a row. But if you end up with tails, heads, tails, heads, 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 you'd stop there also because the only objective is to get 5 in a row. The first part of this problem is trying to find the probability that it takes exactly 10 tosses of the coin to obtain a string of 5 heads results in a row. And if you remembered from before, when you get to 5 in a row, no matter where it is in the 10, you'd stop counting. So the first thing that you have to do is ensure that you don't have 5 coin tosses in a row before the desired time point, which would be from the 5th result to the 10th result. So for the first 4, it doesn't matter what the result is. It could be any A. But for the next one, it needs to be tails. And this is because it enables the next 5 to be heads without any stoppage happening before then. So there's a 100% of any of the results happening throughout this. 1, 1, 1, 1, followed by a 0.5 for the tails and 0.5 for all of the heads following. Because it's a fair coin flip, so there's a 50-50 chance of either result happening. So this would result to the probability of this happening being 1 to the 4th power times 0.5 to the 6th power. Again, because the 1 tails result and the 5 heads results. And if we take a look on the calculator, 1 to the 4th is obviously still 1. And multiply that by 0.5 to the 6th, which would give 0.0156, or a 1.56% chance that this would happen in exactly 10 coin flips. For the second part of this problem, we're looking at the probability that it takes to have at most 10 coin tosses to obtain a string of 5 heads. So with this one, you're taking the sum of the probability for it happening within the first 5, the first 6, the first 7, the first 8, the first 9, and then the first 10. It can happen at any point between 5 and 10 because you need at least 5 to obtain a string of 5 heads, and you could have at most 10 within the given parameters of the problem. The first part of this would be determining the probability that it takes for each of those individual likelihoods to happen between 5 and 10. So for the first one, the probability of you obtaining a 5 string of heads within the first 5 is 0.5 to the 5th, because it's the chance of a 0.5 probability happening 5 times. But with finding how many times it takes for it to happen within 6, the first coin flip needs to be tails so that the coin flips doesn't stop getting counted in the first 5. So it's 0.5 to the 6th with that one. And for the 7th, it is the same. I'll write it down so it's visually understandable. In this, it could be any for the first one, but it needs to be tails, so then you could get a 5 string following that. So again, for 7, for it happening within the first 7, it's 0.5 to the 6th. And this happens again and again, all the way until the 10th, which is also 0.5 to the 6th. So it can happen at any point between 5, 6, 7, 8, 9, and 10. And 5 is the only 0.5 to the 5th, and all of these would be 0.5 to the 6th. And there's 1, 2, 3, 4, 5 of them. So in the calculator, it would be 0.5 to the 6th plus 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 the lone 0.5 to the 5th. And that would give a probability of 0.109 or a 10.9% chance of having a 5 string of heads within the first 10.
Hey guys, so we're looking at what the probability of getting 5 heads in a row within 15 coin tosses is. And we'll calculate the sum of the probabilities of getting 5 heads in a row within the 15 tosses, right? So there's a 50-50 chance of getting a heads or a tails. Hypothetically, let's say you get heads on the first 5 tosses, right? So you get, 5 heads, and there's a 0.5 chance of those happening, each one. So you multiply 0.5 by itself, 5 times. Or you can just say it as 5 to the 5th. Now, let's say your first toss wasn't a heads, you got a tails. And there was a 0.5 probability of that happening, right? And then let's say your next 5 were heads. That's still, 0.5 to the 5th. And you multiply those together, right? And you get 0.5 to the 6th for your 6 rolls or tosses. And let's say it didn't happen in 6 tosses. So you have, any toss here, the A represents heads or tails. And then you need a tails there in case that one was a heads. And there's a 100% probability of this being either number, since it can be anything, so you get 1. And then the, tails is still 0.5, and then the 5 heads is still 0.5 to the 5th. So you get 1 times 0.5 times 0.5 to the 5th, which is, 5 to the 6th though. And this pattern continues until 10. And that's where it changes. So for your 11th toss, say you have 4 here, and any of these 4 A's could be a heads or a tails, and you need this tails here in case hypothetically all of these are heads, right? And then you have another heads or tails, and then you have another tails, and then you have your 5 heads. And this is your 11th toss, like I said. So 1 times 1 times 1 times 1. And then your tails is 0.5. And your another heads or tails is a 1.5. And then your 5 heads are the 0.5 to the 5th, right? So then you get 5 to the 7th. And this pattern continues until you get to 15. Right? So then, to find the sum of all these numbers, you just add them up. Each, sequence, or whatever, probability. So you have 0.5 to the 5th, plus 0.5 to the 6th. So many times. Oh wow. I really messed that up. Plus 6. Or, you could just write 0.5 raised to whatever. Times however many times you did it. Which is 5. And then you get a 0.148. Chance times 100%. So you have a 14.8% chance of that happening. That's pretty dope. Anyways, yeah.